Good morning, friends. So, next topic is on the components of a simulation. So, previous class we had written program on the orbit ripple carry counter. Right. Now, program is fine. Now, what happens is that we need to give the simulation. We need to check the simulation whether we are getting the output correct or not. Right. So, to check the output, we are output. First, we should know what input we have given. Okay. So, building up of a solution, we are having two styles. So that we'll be discussing. We'll take same example of a 4-bit carry ripple counter and we'll check what is the output, how it should be written. Right? So once a design block is completed, so you have completed your writing the main program, it must be tested. The functionality of the design block can be tested by applying the stimulus and checking result. It is a good practice to keep the stimulus and design blocks separate. So two styles of stimulus application are possible. First one is the stimulus block initiates design block. Second one is the stimulates and design block initiated dummy model. Stimulus and design block initiates a dummy top level model. Okay. So we will go with what is this stimulus block, how it should be designed. So earlier we have discussed the design block for the ripple carry counter. So for this ripple carry counter, my input is clock, my input is reset. Okay, and what is my output? Which is Q, which is a vector of a 4-bit. So this is the stimulus block which I need to implement. So for implementing this stimulus block, I will build one dummy variable for building the stimulation. Okay, so this I call it as a stimulus block, and this is called as a design block. So design block, I'm having a clock, I'm having a reset, I'm having a Q, which is the output. I'm having a dummy block, so I'm representing it as a by a D underscore clock, and I'm giving a D underscore reset. Okay, and this dummy value I'm going to force. Right. So why I am giving this dummy value? Because this clock value it will be keep on changing. The reset value also it is keep on changing. So when I give this dummy variables, like I'm giving 0, what will happen? When I give 1, what will happen? So I'm going to check. So that value I'm going to observe. Okay. So I should write a separate stimulus code with all the conditions. Okay. And I should write main program separately. And this main program and this compressed program should match with the variable. That is why always observe that this clock variable, you will have a dummy clock. You have a reset variable, you are having a dummy reset value. And observe the flow. It is from the stimulation value you are feeding from the dummy block to the design block. Okay. And what is the output? Output is getting from the design block to the dummy variable. See, Q value it is going to give C underscore Q. Okay, so the arrow mark it towards this one from the design block to the C of Q. So we will observe this stimulus block. So I have written this program for design block for 4-bit triple carry counter main program. This is subprogram T flip flop. This is subprogram D flip flop. Now this is the output and stimulation waveform. So what is the input value? It is having a clock. I am having the input value reset and I am having the output value 3 is to 0, which is a vector, which is the output Q. See now clock is there. So clock it is alternate zeros and ones. For certain duration it will be 0, for certain duration it will be 1. And this input I need to generate. Next what happen? If reset equal to 1, the output value is 0. Okay. If reset is 1, the output value is 0. If reset is 0, as you can see here, if reset is 0, your counter it is starting. See reset value when it will be active, when I give input 0. Reset when it will be not active, when I give value of 1. So when reset is 1, the output is 0. When reset is 0, then it is a counter program, so it is counting 1, 2, 3, 4, 5, so on, 15, so on. 0, 1, 2. After 15, it is not stopping. It is continuing. Why? Because the reset is still 0. So this is the program I should write. And this program also I should define. And it is a stimulus program which we call. There is a slight difference between a stimulus code and a main code. In the main code, you are declaring input and output variable. But in the stimulus code, you are not declaring, you are getting those values from the design block. So that is why there is a slight change. And what is that change? You can just observe now. So you can observe here there is a module and there is a module name given as stimulus. And you can observe there is no parameter list. Why it is not having list? Because this stimulus program is a part of your main program. So whatever variables will be there, it is directly fed from the main program. Okay, that you need to understand here. So that is why I am not giving any name here. I am giving module stimulus. And here also I am going to declare what is the input register, what is the input reset, and what is the output wire. See, earlier I was to write output Q. Now I am declaring it as a wire. Why? Because Q0, Q1, Q2 are acting as an input and also acting as an output. So I cannot declare it as an input and output. This you should keep in your mind when you are writing a stimulus program. Stimulus program, you cannot write input and output. You should just give the variables it as a registers and wires. Okay, so that it should be in your mind. And what stimulus program you are writing, for which you are writing the program, for which design block you are writing. So only I am writing the file and module name of the ripple counter. R1 input and output. Input is clock and reset and output is Q. Right. So now what I have to do? I should initialize this clock. So initially the clock value is 0 and after 5 seconds, let me say 5 seconds, the clock value change from 0 to 1. So this I need to write program. So how am I going to write? Initially my clock value is 1 bit 0. Set clock bit to 0. Right. Always hash 5. So hash 5 means for every 5 seconds, clock equal to not of clock. So now initially it is 0. After 5 seconds, not of 0, it will become 1. So toggle clock for every 5 time units. So you can see, observe that for every 5 units, it is going to change 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, so on. So this is how we need to generate this clock using these commands. Okay. Next thing is what? If this unit is 5 unit, 5 unit, 5 unit. So your reset pin is 1 for 15 seconds. Then 5 unit, 5 unit, 5 unit, 5 unit. So on till how many seconds? So that I need to make it. So for that one you need to initialize for the reset. Initially it is 1 for 15 seconds. Is it or no? So you observe here initially begin reset equal to 1 dash B1. Hash 15 reset equal to 1 bit 0. So after 15 seconds, the value should become 0. Till what time it should be becoming 0? Till 180 second it will be 1 bit 0. Till 180 time unit, what it will be? The reset will be 0. 0, what will be your output? Output will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, then 0, 1, 2, 3, so on. Till what duration of time? Till the duration of 180 seconds. After 180 seconds, for 10 seconds, it is becoming again 0. Right? So 1 bit 0. So if it is 1 bit 1, now it will become 1 bit 0. Right? Which is 1 bit 0. Right. This is what it happens. Okay. Then after 200 seconds, it is dollar finish. So you need to stop till 200 seconds. So this is the record when reset is 1, it is 0. When it is 0, it is counting for 10 seconds. See 5 unit, 5 unit, 10 seconds, it was 1. The output is 0. Then afterwards again it has been done. So till 200 seconds it will be there. So running. So this is how you need to write the stimulus program for this one. And you need to monitor initial monitor $time output Q equal to percentage D Q. So Q you are going to output which is 0, 1, 2, 3, 4, so on 15, 0, 1, 2, 0, 1. So this is how you need to write, and this can be tabulated. So this is what you can tabulate the value. So at 0 second 0, or 20 second 1, 30 second 2, 3, 4. Why? Because for every positive cycle we have written. So till this point it was 0, right? 200 second. Then what happens? The value will be 0. Again it has come. So this is the output of this simulation which you have been received. And this is how you need to write the stimulus code for the 4-bit ripple carry counter. A dummy variable initialization, then writing program for the clock value which has been shown here. Okay, then writing program for the reset value which is shown here, then monitoring the output value. So this is your stimulus program output results which you need to observe it. Okay, thank you.